Have you ever felt like time is flying by, or maybe dragging on forever? What if I told you that's not just a feeling, but a fundamental property of our universe? Einstein's theory of relativity reveals a mind-bending truth. Time isn't constant. For a moving clock, time actually slows down compared to one that's standing still. This isn't science fiction. It's a proven scientific fact called time dilation. So, how does this cosmic time machine actually work? Let's dive in. First up is velocity time dilation. Imagine you have a pair of identical twins. One stays on Earth, while the other blasts off into space on a super-fast rocket, traveling near the speed of light. After what feels like a few years for the space-traveling twin, she returns to Earth. But when she lands, she finds her twin is now an old man. This is the famous twin paradox. For the astronaut, time literally passed more slowly because of her incredible speed. The faster you move through space, the slower you move through time. It's a trade-off built into the very fabric of reality. So, if you want to stay younger, maybe just start running everywhere really fast. Just kidding. Mostly. But speed isn't the only thing that can warp time. Gravity does it too. This is called gravitational time dilation, and it's a key part of Einstein's theory of general relativity. He realized that massive objects, like planets and stars, don't just pull on things. They actually bend and warp the fabric of spacetime itself. The stronger the gravity, the more spacetime is curved and the slower time passes. Think of it like a bowling ball on a trampoline. A heavier ball creates a deeper curve. Time near a massive object is like being deep in that curve. It has to travel a longer path, so it appears to move slower to an outside observer. This effect is very real and incredibly important. Without accounting for it, our GPS systems would be useless. Satellites orbiting Earth are in a weaker gravitational field than we are on the surface. This means time for them ticks slightly faster. Engineers have to constantly correct for this tiny difference, or your GPS would send you miles off course every single day. So, we have speed and gravity, both playing tug-of-war with the flow of time. What happens when you combine them? Look no further than the astronauts aboard the International Space Station. The ISS is whipping around the Earth at about 17,000 miles per hour. Because of this high velocity, their clocks tick slightly slower than ours. However, they are also farther away from Earth's gravitational pull, which means their clocks should tick slightly faster. So which effect wins? In this case, the high-speed effect is stronger. The result is that astronauts on the ISS age just a little bit slower than we do down here on Earth. After a 6-month mission, they return about 0.05 seconds younger than they would have been if they'd stayed home. It's not exactly the fountain of youth, but it's a perfect real-world example of relativity in action. So, from the twin paradox to the GPS in your phone, the elasticity of time is all around us. Time isn't a rigid, universal clock ticking away at the same rate for everyone. It's a flexible, dynamic dimension, intertwined with space in a four-dimensional fabric we call spacetime. Every time you move, every time you climb a flight of stairs, you are subtly altering your own personal journey through time. The universe isn't just a stage where events unfold. It's an active participant, constantly shaping the very flow of our existence. Thanks for watching, and if you enjoyed this journey through spacetime, be sure to like and subscribe for more cosmic adventures.